Okay, so we are going to be finishing Chapter 1, Section 2 that's on literal equations, and then probably starting Section 3. Hopefully finishing it, I don't know. Depends on how much time we have. All right, but again, this is where we're solving for a given variable. So it gives us this equation, C equals 5/9 times F minus 32. Does anybody recognize this formula? Fahrenheit and Celsius, changing between the two. So now we're going to isolate the F in this equation. So I'm trying to get F by itself. So I start with what's the farthest away from the F? That is the 5/9. Okay, I need to get rid of 5/9. So how do we get rid of multiplying by 5/9? You can think dividing by 5/9, but we don't really divide by fractions. We would multiply by the reciprocal, absolutely. So if I multiply both sides by 9/5, that leaves me with this little gem, right? 9/5 times C is 9/5 C equals, then 9/5 times 5/9 goes away, F minus 32, and then move the 32 to the other side. So 9/5 C plus 32 equals F. Okay, here's the next one, D. AX plus BY equals C, and we're going to isolate the Y. So I want to get Y by itself. So I'm going to move this AX to the other side, and it becomes negative. That leaves me with BY equals C minus AX. And then I have to divide both sides by B. So that leaves me with Y equals C minus AX over B. Of course, what this is the standard equation for a line, right? Linear equation. So you can see this is, if you wanted to think of it, negative A over B. That's just the same thing as your slope, right? And the C over B is your y-intercept. If you break that even farther apart, and it's in that y equals mx plus b form. Right here we've got some ugly subscripts, and we've also got some exponents in this. So S sub n equals a sub 1 minus a sub 1 times r to the nth all over 1 minus r. And I'm wanting to isolate the a sub 1. So when I look, what's the initial problem with isolating for a sub 1? Well, the initial problem is there's two of them. That's what I'd want to fix first. Okay? I mean, you could probably do it the way you were trying to do it, but the first thing I would do is rewrite those as 1. Well, I'm not saying yours is any worse. So this is a sub 1, 1 minus r to the nth over 1 minus r. I factored out an a sub 1 like we did yesterday. When you have two of them, you have to rewrite them as 1. Now you can think about this next thing in 1 step or 2 steps. I'm going to explain it in 2 steps. Alright. I want to get rid of this 1 minus r in the denominator so I can multiply by 1 minus r on both sides. So when I do that, that leaves me with 1 minus r s to the n equals a sub 1 times 1 minus r to the n. And now then I want to divide by 1 minus r to the n on both sides. And when I do that, that leaves me with a sub 1 equals, let's change the color so we don't all bleed together. A sub 1 equals 1 minus r times s sub n. Let's make it like a subscript. There we go. Over 1 minus r to the nth. Okay, and here's the last one from section 2. Write a formula that expresses the width W of a rectangle as a function of its area A and its length L. So what is a formula that you know that involves those three values?
Area equals length
the area is equal to the length times width when it's a rectangle. Area equals length times width. Absolutely. Now then we have to isolate it for what? It expresses the width in terms of its area and its length. So I want to get width by itself. So the hard part of that one is knowing the formula, coming up with it. Because now then, to get width by itself, it's being multiplied by length. So we divide by length. So we would say the width is equal to the area of the rectangle divided by the length of that rectangle. Okay, so we're starting 1.3. It's going to be a review here at the beginning of the Cartesian coordinate system. You may have heard of it called the coordinate plane, right? Or XY axis, right? However you say it. It's Cartesian coordinate system is the way this book talks about it, right? Which means for X and Y that are real numbers, then if I write parentheses X comma Y, that's called an ordered pair. And it's real numbers inside of it, right? So again, stuff that we should know. If we were to graph it, right here, this point is called the coordinate point, X comma Y. So what would that coordinate point be? Well, if I count it over, that's 5, that's 4. So we would write that as 5, 4. All right, what about that red point? What's that say that is? That is the origin, right? And it's the ordered pair 0, 0. Again, shouldn't be anything that you haven't seen before. All right, here's an example for us. In which quadrant, if any, are the points? Okay, so let's do it one at a time. -2, 6, what quadrant does that put me in?
2.
So you'd start here, -2, 6. That is in the second quadrant. All right, and again, we use Roman numerals to show the quadrants. So that first one is in quadrant 2. What about 0, -1? Where would that put me?
On the x-axis.
Okay. Then that's not in a quadrant, is it? 0, -1 puts you right on the x-axis. So that's going to be your answer there. If it asks where that's at, it's on the x-axis. All right. What about 5, 3? You're going to go right 5, up 3. What quadrant is that? The first quadrant, yes. And then -4, -4. That puts you in the third quadrant. Hi, just kidding. You all failed my test. 0, -1 should be on the y-axis.
Seems like the ones with...
I knew that this whole time. I was just testing you. Okay, here we're going to be plotting points. So first it tells me to plot the point 3, 5. So again, I start at the origin. I'm going to go right 3. I'm going to go up 5. There's my point that I'm plotting. Boom. You like that? Boom.
Yes.
Now, 4, -5. I'm going to go right 4. I'm going to go down 5 because it's negative. And that point's going to be here. Yes, Jacob. Boom. -3, 4. I'm going to go left 3. I'm going to go up 4. Shimona. -2, -5. I go left 2. I go down 5. Yeah, whatever. And then 0, 2. I stay here and I go up 2. It seems to me that the ones that are on an axis are the ones people confuse the most. I don't know why, but that is the ones that people are more likely to mess up. So just be careful on those. Right here is the distance formula. So we've just seen where that comes from. All right? Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Whether you know where it comes from or not, luckily you don't have to know that for Math 112. You just have to know how to use it. So let's use the distance formula here. So I'm going to zoom in because, boy, those numbers are small. So let's say that This is my x1, this is my y1, this is my x2, this is my y2. The only way you can mess this up is if you swap which one goes where. Alright? So make sure that if you call this x1, don't call this y2. Okay. Now, it probably won't matter for distance formula because you square it and it goes to positive anyways. But that can mess it up. Like when you're doing slope formula, people mess that up. I don't know why, but it happens. So, if we do the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, that's going to be the square root of 36 plus 9. Double check my math. So I got radical 45, which is 3 radical 5.
Indeed.
Is that what y'all got?
Tis.
Yeah. Slop.
Now right here we've got 2 points, and my x coordinates are in terms of pi. So that may be a little unusual from what you're used to seeing. But if you take Math 113, you'll see stuff like this all the time, and you'll get so used to it, it won't even bother you. But let's say this is x1, this is y1, this is x2, this is y2. I'm going to plug it into my distance formula. So the distance is equal to x2, so that's pi over 3, minus x1, pi over 2, squared, minus y2 minus y1 squared. So now to simplify that, that's negative pi over 6. Square it, that's going to be pi squared over 36 plus 1. And so now you can do a little finagling with that. This can equal the square root of pi squared plus 36 all over 36. And then the square root of 36 is 6. So this is the square root of pi squared plus 36 over 6. That's probably the way it'll be written on your homeworks. Okay, midpoint formula. Well, when you think midpoint, you should think average, halving, finding the middle, right?
I would say half
I
the
mean,
distance.
it's the mid.
If you know the distance between it is half of that. But I think about finding the average is the midpoint. So the one thing that drives me crazy is people say, I need that midpoint formula. You don't, it's an average. You add the two x's and divide by 2. It's an average. The y's, you add the two y's, you divide by 2. It's an average. I could go home and memorize this midpoint formula. I hope not. I hope that you know it's an average. And you can find the average of, what's the average of mine and your age?
How old are you?
27.
27. You're 16. I'm still 16. Like 2 weeks. That's 21 and a half.
Okay, I didn't know how old you were. It's 22 or 21 and a half, right? Did you have to use this formula?
Yes. Plug directly in my brain.
Thanks. So just find the average of the two. So right here, we're given these 2 points and told to find the average. Or not the average, the midpoint. Find the midpoint of these 2 points. So I add my x's. 5 and negative 1 is 4. Half it, 2. Negative 3 and negative 6. Add those. Negative 9, half it. Negative 9 halves. Here's the midpoint.
Whoa.
Now, if you want to, you could rewrite negative 9 halves as negative 4.5. If that helps you put it on a graph, if you're required to do that. Okay, so here on our circle, the equation for a circle is x minus h squared plus y minus k squared equals r squared. Well, what does that look similar to again? Pythagorean theorem, okay? Same looking thing. Distance formula, Pythagorean theorem. It's the same. It's derived from the same thing. All right? Now, a circle that's centered at the origin. Well, what would the equation for that be? Well, it tells us x squared plus y squared equals r squared. All right? Well, that makes sense because if my h were 0 and my k were 0, because it's centered at the origin, well, x minus 0 squared is x squared. Y minus 0 squared is y squared. Equals that r squared. And then, even a step further, do you know what it's called when you do a circle centered at the origin whose radius is 1?
Arc.
You know what that's called?
Circle centered at the radius.
It's centered at the origin with a radius of 1.
That means that its diameter is 2.
Yeah, that's true.
That's called a unit circle. Okay? Centered at the origin with a radius of 1 is a unit circle. Again, a very heavy topic in Math 113. But anyways, I digress. Example 4, which is graphing a circle. Sketch the graph of the equation x minus 1 squared plus y plus 2 squared equals 9. So again, your homework is going to have a nice circle graphing tool. You will choose the circle tool that they've got. You click where the center is, and then you drag the radius out. It's so nice how it works. Okay? It really is kind of neat. But for our case, I don't have a graphing tool. I've got a good old XY plane here. Coordinate plane, Cartesian plane. So, when I graph a circle, the first thing I need to know is where is the center. So from this equation, where would the center of this circle be?
-1 and 2.
Incorrect. It's at 1 and -2.
It's the opposite.
Because the formula has a built-in negative, right? X minus h and y minus k. It means it's the opposite signed. Mm-hmm.
I want to do something. So that's the what of the circle?
That is the center of the circle.
That means the origin. Right?
It's the center of the circle.
The origin.
It's not at the origin. If you want to think, but we're not going to call it the origin. I'm going to call it the center. There is no origin of a circle. A long time ago, let me tell you a story about where it came from. I don't know. That's what an origin story is.
The origin is the 0, 0 on a coordinate plane.
So right here would be the center. It's at 1, -2. And now what is the radius of my circle?
3.
Thanks. It is 3. Right? The constant at the end is 9, and that is my radius squared. Right? It says it's the r squared. So you take a square root of that constant to get the radius of 3. So how can I show a radius of 3 on a graph like this that I'm doing on my own? I count 3 in the 4 main directions. So I'm going to go to the right 3. I'm going to go to the left 3. I'm going to go up 3. And I'm going to go down 3. All right? So if I ever have to graph one by hand, that's the way I do it. So that way you know, hey, I've counted 3 in every direction. And there's my circle. It's not pretty, but it's effective. Okay, here. We're going to write an equation for this circle. Write the standard equation for a circle that's centered at -3, 5, and it passes through the point 1, 8. So what do I know? I know the center. That's good. I need to know the center of a circle. What else do I need to know? I need to know the radius to write the equation.
You use the distance formula?
The distance formula. OMG. Yes. That's it. I just want to know the distance from the center to the edge. So I use those 2 points, the center and the edge, in my distance formula. So that's going to be x2 minus x1 squared plus y2 minus y1 squared.
Does it matter which one is x1, which one's x2?
No, just stay consistent.
Okay.
So this is going to be 4 squared plus 3 squared, which is 5. So now I know the radius is 5. I know the center is at negative 3, 5. So let's put that in the equation of a circle. So it's x minus h. So minus negative 3 is going to be plus 3 squared plus y minus k squared equals r squared.
Okay.
Last couple problems here, so let's try to get them finished. I think we may have just enough time. We've got linear equations here, so we're going to be graphing lines. So right now, they're in standard form, right? ax plus by equals c. And we're told to graph lines showing intercepts. Then it says to graph each equation, be sure to find and show the intercepts. So since it's stressing to me to graph by showing the intercepts, then I'm not going to put this in slope-intercept form. All right? I know, that may be what you're trained to do. That's the best way to graph. And it is one of the best ones is put it in slope-intercept form. But really, all you need to graph a line is you just need 2 points. Through any 2 points, there exists only one line. So if I'm going to have to show the intercepts, then I'm going to graph by finding the intercepts.
0. So you plug in any 2 numbers, right?
So I want to find the x-intercept and the y-intercept. Now, what do we know is true of any x-intercept? Any of them.
It all has the y is 0.
The y is 0, absolutely. On every single x-intercept you'll ever have, the y value is 0. Yeah, I've shown you this before. So, if I need to find an x-intercept, I simply plug in 0 for y. If I plug in 0 for y, that gives me 2x is equal to 9, which means the x value is 9/2. So that's 1 point on that line. Now to find the y-intercept, what's true of every y-intercept?
The x is 0.
X value is 0, so I plug in 0 for x. When I do that, I get negative 3y equals 9, which means the y value is negative 3. So my points are at negative 3 on the y-axis and at 4.5 on the x-axis. Oh. And so through those 2 points is my line. Again, on your homework, there's going to be a graphing tool. And guess what? There's 2 points that it makes you show. If it makes you show the intercepts, put those bad boys on the intercepts. And it'll draw the line for you. You just drag the 2 points.
Indeed.
All right?
Slope would be 2/3, right?
Now, B. I've got y is equal to 40 minus x. So same thing. They're making me stress finding the intercept. So let's do that. My x-intercept will be when the y value is 0. So if I plug in 0 for y, I get 0 equals 40 minus x. Move the x over. And so that's going to give me a 40 there. And then the y-intercept, I plug in 0 for
Wow.
x. And when I do that, it gives me a y-intercept of 40. I tell you what, this graph cannot contain my line. So